The Disney bomb, also known as the Disney Swish, officially the 4,500 pounds concrete piercing/rocket-assisted bomb, was a rocket-assisted bunker buster bomb developed during the Second World War by the British Royal Navy to penetrate hardened concrete targets, such as submarine pens, which could resist conventional free-fall bombs. Devised by Royal Navy Captain Edward Terrell, the bomb was fitted with solid fuel rockets to accelerate its descent, giving it an impact speed of 990 miles per hour, 1,590 kilometers per hour, substantially beyond the 750 miles per hour, 1,210 kilometers per hour, free-fall impact velocity of the 5-ton tallboy earthquake bomb for comparable purposes. The Disney could penetrate 16 feet, 4.9 m, of solid concrete before detonating. The name is attributed to a propaganda film produced by the Walt Disney Studios, that provided the inspiration for the design. The Disney bomb saw limited use by the United States Army Air Forces in Europe from February to April 1945. Although technically successful, it initially lacked the pinpoint accuracy required for bunker targets. It was deployed late in the war and had little effect on the Allied bombing campaign against Germany. Background: during the Second World War, Barnes-Wallis developed two large earthquake bombs for the Royal Air Force, the 5-ton Tallboy and the 10-ton Grand Slam, for use against targets too heavily protected to be affected by conventional high-explosive bombs. These enormous weapons were designed to strike close by their target, to penetrate deeply into the earth, and to cause major structural damage by the shock waves transmitted through the ground. In practice, they proved capable of penetrating a significant thickness of concrete if they scored a direct hit, despite not being designed for that purpose by Wallis, who had to work within the accuracy limitations of current bomb sights and the resulting low accuracy of the bombings. The Disney bomb, by contrast, was designed from the start to penetrate the thick concrete roofs of fortified bunkers. Whereas the earthquake bomb's target was the bunker itself, the Disney bomb's target was the bunker's contents. To this end, the warhead was composed of an unusually thick steel shell containing a comparatively small amount of explosive. It was much slimmer than was usual for aircraft-dropped bombs, and a cluster of booster rockets accelerated the weapon as it fell. These features accord with Newton's approximation for impact depth and the empirical design equation known as Young's equation that states that the deepest target penetration is achieved by a projectile that is dense, long, and thin, i.e. has a large sectional density, and strikes with a high velocity. Description: the CP/RA Disney bombs were 16 feet 6 in, 5.03 m, long and weighed 4,500 pounds, 2,000 kilograms. The diameter of the body of the bomb was 11 in, 280 millimeters, while the diameter at the tail was 17 in, 430 millimeters. They were composed of 3 sections. The forward section was the warhead, an explosive charge of 500 pounds, 230 kilograms, of shell light, contained within an armor-piercing casing of thick steel and fitted with 2 British No. 58 MKI tail pistol fuses at the base, i.e. furthest from the nose. The second section was made up of 19 rocket motors from the 3-inch rocket projectile, essentially metal tubes filled with cordite. In the third rear section, a tail cone contained the circuit that ignited the rockets. This was powered by a small generator with a vane spun by the airstream going past the falling bomb. Rocket ignition was controlled either by a time delay switch, or a barometric switch. There were 6 small fins at the rear of the bomb for its stabilization. The bomb was suspended from the aircraft by 2 weight-bearing lugs. 3 arming wires also connected the bomb and the aircraft. As the bomb dropped, a brief tug from the wires would arm the warhead fuses and the rocket ignition circuit, and unlock the electrical generator, allowing it to spin freely. For accuracy, the bombs had to be dropped precisely from a predetermined height, usually 20,000 feet, 6,100 m. They would free fall for around 30 seconds until, at 5,000 feet, 1,500 m, the rockets were ignited, causing the tail section to be expelled. The rocket burn lasted for 3 seconds and added 300 feet per second, 91 m/s, to the bomb's speed, giving a final impact speed of 1,450 feet per second, 440 m/s, equivalent to 990 miles per hour, 1,590 kilometers per hour, or approximately Mach 1.29. Post-war tests demonstrated the bombs were able to penetrate a 14-foot 8-inch, 4.47 m, thick concrete roof, with the predicted, but untested, ability to penetrate 16 feet 8 inches, 5.08 m, of concrete. Development and testing. According to an anecdote, the idea arose after a group of Royal Navy officers saw a similar, but fictional, bomb depicted in the 1943 Walt Disney animated propaganda film Victory Through Air Power, and the name Disney was consequently given to the weapon. The Royal Navy developed the bomb even though the Fleet Air Arm operated no aircraft capable of carrying it. The Navy was interested in a concrete penetrating weapon due to the German Navy's extensive use of fortified submarine pens to protect their U-boats and E-boats from air attack while docked. The Disney bomb was devised by a British naval officer, Captain Edward Terrell of the Royal Naval Volunteer Reserve, who served in the Directorate of Miscellaneous Weapons Development. Before the war, he had been a lawyer and the recorder of Newbury. However, he was also an enthusiastic inventor and had filed several patents pre-war, including ones for a vegetable peeling knife and a bottle for fountain pen ink. The bomb's development began in September 1943. Although there was support for the idea at the highest levels within the Admiralty, production of the weapon would have to come under the Ministry of Aircraft Production, MAP. The Road Research Laboratory provided theoretical formula for penetration from U.S. data on the performance of 15-inch, 381 mm, shells against reinforced concrete, and the Chief Engineer of Armament Development at Fort Halstead prepared a preliminary design to present to the MAP. In the face of opposition, the First Sea Lord prepared a memorandum for the Anti-U-Boat Committee, of which Churchill was the chairman. Terrell visited Churchill's scientific advisor Lord Charwell to convince him that it was feasible technically. Due to the Prime Minister's absence through illness, it was not until January 1944 that Churchill expressed a desire that the bomb should be considered by the committee. Due to the number of departments involved, there were meetings involving large numbers of technicians and scientists to confirm the technical feasibility. Terrell received support through the Air Technical Section of the USAC, and was able to show the Admiralty a mock-up under the wing of a Boeing B-17 Flying Fortress. The Air Ministry was still opposed to its development on several technical grounds, and it took a meeting of the War Cabinet in May, which Terrell attended, to decide in its favor, giving it P+ priority. As a side effect, the meeting focused attention on the issue of the U-boat shelters, and the RAF were directed to make attacks on them, dropping 26 tallboys in August that year. Despite being a British weapon, Disneys were used only by the United States Army Air Force, with the bombs becoming a joint project between the American 8th Air Force and the British Royal Navy. They were never used by RAF Bomber Command. The 92nd Bombardment Group was initially tasked with their use. The bombs were also dropped by the 305th Bombardment Group and 306th Bombardment Group. The 94th Bombardment Group prepared to use the bombs, but flew no operations with them before the war in Europe ended. The B-17 Flying Fortresses operated by these units carried the bombs in pairs, one was slung under each wing, as they were too long to be carried in the B-17's bomb bay. The Disneys were carried from the same external mounting used for the Aero-Enka GB-1 glide bomb. Cameras were also fitted to the aircraft so the bomb's trajectory and effect could be recorded. Testing of the Disney bombs began in early 1945. Bombs were initially dropped on a bombing range near Southampton to photographically record their trajectory and calibrate bomb sights. This was necessary as the flight path of a rocket-accelerated bomb differed considerably from that of a free-falling bomb. Test drops were then conducted on the Wadden Bunker, German codename Kraftwerk Nordwest, now known as the Blockhaus des Perlex, a large German concrete bunker near Wadden in northern France. This was ideal for the purpose as the area had been captured by Allied forces in September 1944, so damage to the structure could be inspected after bomb tests. 4 bombs, carried by 2 B-17s, were used and 2 hits scored on the target. The resultant damage was considered satisfactory by Royal Navy observers on the ground. Combat. The first Disney attack was against the port of IJmuiden, Netherlands. This was the site of 2 separate fortified pens used by the German Navy to house their Schnellboot, fast torpedo boats, known to the Allies as E-boats, and Biber-midget submarines. The older structure, codenamed Schnellboot Bunker I, SBB-1, was protected by a 10-foot, 3.0 m, thick concrete roof. The newer one, codenamed Schnellboot Bunker B, SBB-2, had 10-12 feet, 3.0-3.7 m, of concrete, with a further 2 4-foot, 0.61-1.22 m, layer separated by an air gap. The E-boats laid up in the shelters during the day, safe from air attack, and put to sea under cover of night to attack Allied shipping. The pens were priority targets as the torpedo boats they protected were a considerable threat to the supply lines serving Allied forces in Western Europe. Since August 1944, the 2 bunkers had been attacked 4 times by No. 9 Squadron and No. 617 Squadron of the RAF, with a total of 53 of the 5-ton, tallboy earthquake bombs. There had been numerous other attacks from bombers carrying smaller, conventional bombs. 9 aircraft of the 92nd Bomb Group, carrying 18 Disneys, attacked Schnellboot Bunker B, SBB-2, on February 10, 1945. Royal Navy intelligence learned the concrete had been penetrated, but the pens had been empty at the time of the attack. The 92nd therefore carried out an attack on the SBB-1 pen, again with 9 aircraft, on March 14. On March 30, 36 aircraft from the U.S. 8th Air Force, including 12 from the 92nd Bomb Group, attacked the Valentine submarine pens, a massive, bomb-hardened concrete shelter under construction at the small port of Farge, near Bremen in Germany, location, 53°1300 and 8°3015 E, with Disney bombs. The shelter was nearing completion and was to be a factory for the assembly of Type XXI U-boats. Construction had been underway since 1943, using the forced labor of 10,000 concentration camp prisoners, prisoners of war and foreign civilians, Fremdarbeiter, who suffered a high death rate because of the horrific conditions they worked under. Valentine's 4.5-meter, 15 feet, thick roof had already been damaged by 2 10-ton Grand Slam bombs dropped by the RAF 3 days earlier, on March 27. During the 8th Air Force attack more than 60 Disneys were launched, but only 1 hit the target, with little effect, although installations around the bunker received considerable damage. After the bombing, the Germans made limited attempts to carry out repairs before abandoning the complex. The area was captured by the British Army 4 weeks later. On April 4, 1945, 24 B-17s attacked fortified targets in Hamburg. The target was obscured by clouds, so radar guidance was used to launch the bombs. A further mission in May 1945 was cancelled. A total of 158 bombs were dropped before the end of the war. No aircraft or aircrew were lost during the 4 Disney combat missions. Post-war development. In June 1945, the Air Council wrote to the Lords of the Admiralty expressing their appreciation of the work that had been done on the rocket bomb. The RAF initiated bombing tests of the Disney in June 1945, using the Wadden Bunker as a target. The actual bombing was carried by the U.S. 8th Air Force on behalf of the RAF. However, Wadden proved too small to be a satisfactory target, and the French objected to continued bombing of their territory in peacetime. Further testing took place as part of Project Ruby. This was a 1946 joint Anglo-American program to test a range of concrete-penetrating bombs against a wartime German bunker on the small island of Heligoland and the Valentine submarine pens. Bombs tested included the Tallboy and the Grand Slam, both British and US-made versions, the American 22,000 pound, 10,000 kilograms, Amazon and 2,000 pound, 910 kilograms, M103 SAP bombs, and the Disney. The bombs dropped on Valentine were inert, as the objective was not to observe the effects of bomb explosions, but rather to test concrete penetration and the strength of the bomb casings. Also, with the restoration of peace, the safety of civilians living around Valentin had become a consideration. Heligoland was uninhabited at the time as its small population had been evacuated during the war. It was the site of a U-boat pen with a 10-foot, 3.0 m, thick roof. This was used to test bombs loaded with explosive but with inert detonators, to make sure the explosives used would not themselves detonate immediately upon impact with the target, before penetrating it. This peacetime testing of the bomb was far more extensive than could be carried out prior to its wartime deployment. A total of 76 Disneys were dropped on Heligoland, loaded with a variety of explosive charges, composed of shell-light, RDX, TNT, or picratole. 34 Disneys were dropped on Valentin, 12 with the rockets inactivated and 22 with the rockets firing. A further 4 had been previously dropped on a bomb range at Orford Ness to test their accuracy, and to make sure none would land outside the safety exclusion zone that was set up around Valentin during the trials. The penetration performance, 14 feet 8 inches, 4.47 m, of concrete, of the Disney was found to be satisfactory, with a predicted maximum penetration of 16 feet 8 in, 5.08 m. One of the bombs penetrated both Valentin's concrete roof, and its 3-foot, 0.91 m, thick concrete floor, coming to rest completely buried in the sand under structure's foundations. However, there were problems with the bombs. The reliability of the rocket booster ignition was considered unsatisfactory, with a failure rate of around 37% during the trials. Also, some bombs broke up on impact with the target due to flaws in the steel casing, and bombs struck at an angle, increasing the effective thickness of concrete they had to penetrate. Furthermore, it was noted that the warhead of the bomb was comparatively small, so a very large bunker complex such as Valentin would have required many penetrating hits to be sure of destroying all the contents. In comparison, the effective concrete penetration of the Tallboy and Grand Slams was similar to the Disney, around 14 feet. Although these bombs directly penetrated only around 7 feet of concrete, the remaining thickness was blown in by the detonation of the bomb's enormous explosive charge. The roof of Valentin had been penetrated by 2 Grand Slams before the war ended, but, as there was no detonation inside the bunker, there was little damage to the complex aside from the large holes in the roof. Post-war examination revealed installations inside the bunker remained comparatively unscathed. The conclusion of Project Ruby was that none of the bombs tested was completely suitable, and the development of a new concrete-penetrating bomb was recommended. The Disney's rocket assist was viewed as a worthwhile feature that should be incorporated into any new bomb designs because target penetration increases with strike velocity, although penetration increases only marginally from drop altitudes higher than 20,000 feet, 6,100 m. On January 27, 2009, the body of an inactive Disney bomb, with its 500-pound, 230 kilograms, explosive charge, was extracted from the roof of Wadden Bunker, by now a private museum, where it had embedded itself during one of the 1945 test drops. The bomb was transferred to the ammunition depot at Lajayul Drs 2 km from the center of Vimy, where recovered chemical ammunition and equipment from the First World War is processed.
Please subscribe and thanks for watching.